Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I hope everyone is safe, and it's never too late to say Selamat Hari Raya to everyone. Alright, so this video we discuss for week number 10 for the first lesson. We call differential equation by using separable method. Okay, so let's take a look at this slide. Separable method. Okay, so first thing first, we understand about the introduction of differential equation. A differential equation is an equation that involves differentials or derivative and a function that satisfies such as equation is called a solution. Okay, so actually for differential equation you must understand these two type of solution or two type of equation. Number one, general solution. General solution ni without any derivative in that equation. Contoh, let's say you have paling simple ya. Let's say you have x plus y equal to 4. Okay, so it's not necessary to put y as a subject as long as you have only an equation without any derivative. Okay, because when you have a derivative in one equation, that one we call as a differential equation. Contoh macam ni lah, dy over dx equal to 2x over y squared. And it's not necessary to put this dy over dx as a subject. Actually, you boleh rearrange become y squared dy over dx equal to 2x. And this one pun kita panggil sebagai differential equation. Okay, contoh yang ini kita panggil sebagai first order differential equation. Okay, let's say you have x d squared y over dx squared plus y cube equal to 4. Ini kita panggil sebagai second ODE, tapi your level is only for first order differential equation. Right? Again, it's not necessary to put your dy over dx as a subject. Maknanya bukanlah in order to identify whether your equation is a differential equation or not, it's not necessary you put the dy over dx as a subject. Sometimes your equation, okay, suddenly your dy over dx lies at the middle of the equation. That one pun kita panggil sebagai differential equation. Alright. So our objective today is when they give you differential equation, this kind of equation, how to change become the general solution. Daripada differential equation, we wanted to change to the general solution. Okay, so method dia kita panggil sebagai separable method. Alright. So this one is also another example for differential equation. Ini adalah first ODE, first order differential equation. This one is also first order differential equation because the highest power of the d over here ataupun the differential is only for first derivative. But for the third equation over here is a second order. Again, dia tak masuk dalam syllabus lah. Alright. So differential equation used intensively in modeling application, especially those that involve one or more rate of change. Okay, contoh, for example, let's say we wanted to calculate the rate of interest. Sometimes they include the third ODE. Okay, ada banyak lagi example that you can use later, especially happen in the financial problem lah. Okay. Okay, so the simplest kind of differential equation has the form of dq over dx equal to gx. Actually, q ni is only a parameter lah. You might substitute with any variables that you want. Usually kita gunakan dy over dx lah, in which the derivative of the quantity qx is given explicitly as a function of the independent variable of x. Okay. I just want to highlight over here. It's very important to identify which one is the dependent, which one is the independent variables. Okay, usually kita akan letkan x ni sebagai independent. Okay, because y is depend to x. Y depend to x. Alright, which is any changes about x will affect the y variable. Okay, so usually kita akan put as an x ni independent, they stand alone, but for y is depend to x. Right, so y is the dependent variables. Kenapa kita kena faham betul tentang dependent and independent variable? Because later kan I dah mention just now, our objective is to change from differential equation become the general solution, right? Okay, so you kena tahu which one should be the subject to that equation in the general solution. Okay. Alright, so kita tengok example lah. Such a differential equation is solved by finding the indefinite integral of gx, that is qx equal to capital Q equal to integrate the gx dx. Meaning, in order to change from this differential equation become Q, you have to integrate the gx dx. Okay, so our objective is to change from differential equation become the general solution, right? So in order to identify our capital Q, or our dependent variable is to integrate the function of x. Okay, right, so as an example, I'm using this example, dy over dx equal to x squared plus 3x. Okay, in order to get our dependent variable, which is y, so we have to integrate with respect to x. As simple as macam you bring up the dx ni, put over here just behind the function of x squared plus 3x, and then you integrate. Alright, so, and if you notice, you akan dapat plus c lah, because this is a definite integral, so you have to put the plus c. So this is called our general solution. Okay, kalau you tak nak letakkan y as a subject, maybe you boleh letakkan x as a subject, tapi usually you put y lah, because y is our dependent variables. Okay, alright, and don't forget to put the plus c. Okay, because c is a constant of integration. Alright, so this is the method, separable equation or separable method. Usually your differential equation consists of x and y variable together. Dy over dx equal to hx over gy. You have two variables in one differential equation. Usually memang macam tu lah. Reason dia because kita boleh separate x with x, y with y. So therefore, in order to solve our differential equation, you have to separate x with x, y with y, like this. Okay, so next, put the symbol of integration, because our objective to solve our dependent and independent variables, right? So therefore kita put a symbol of integration. Okay, therefore you akan dapat integrate gy dy equal to integrate hx dx. Remember, x with x, y with y. Right, tak boleh lah you nak integrate gy but with respect to x. Salah, so you have to put as a dy jugalah. Okay, so let's try this one example. Find the general solution of the differential equation dy over dx equal to 2x over y squared. Okay, ini very direct. Usually soalan akan bagi awak in the form of y squared dy over dx equal to 2x. Find the general solution. Actually, you boleh pindahkan teruslah ni ke atas. Okay, dx. Alright. Okay, let's take a look how they solve this example. So to separate the variables, pretend that the derivative dy over dx is actually a quotient and cross multiply to obtain y squared dy equal to 2x dx. Okay, yang ni jangan skip the step. Actually, you have to put, you have to show how you separate the variables according to the variables lah. Now integrate both sides of this equation to get integrate of y squared dy integrate 2x dx. So therefore, you akan ada dua constant C1 and C2. Okay. Kenapa kena ada C1 dan C2? Because both integration will produce a constant of integration. Therefore, kita label lah C1 and C2. Tak nak label C1 C2 boleh, label lah A and B. As long as you can show that once you integrate, you will produce a constant of integration. Okay, what we need to do with the C1 and C2? Actually, you boleh move to the left or move to the right. Tapi doesn't really matter. Yang penting, you put as a plus C. Plus. Jaranglah kita letak negatif. Okay, usually kita put as a positive. Alright. Okay. And this one is very subjective. Okay, very subjective. Either you want to, kalau you tengok sini, they solve, they keep the Y at the left hand side. This is the left hand side, this is the right hand side. You can see from here, they keep the Y at the left hand side. Okay, ini you just play around with the algebra over here. For example, over here you have 1/3, so you boleh, in order to eliminate this 3, you boleh multiply the whole thing with 3. Multiply the whole thing with 3 together with the constant. Okay, together with the constant. Sebab tu kat sini dapat 3C3. Later baru you put as a big C, in general C lah. Okay, and after that baru you pindahkan this cube become power of 1/3. Okay, clear Okay. So this one is from delta. Okay, this is from delta. Okay, so kalau you notice, this equation consists only one variable of x. Kalau tadi dia ada y, ada x, right? For example, x over y squared. Tapi kali ni dia ada x. What happen is, actually, dia adalah multiply with, dia ada actually divide with 1 ke, multiply with 1 ke. Okay? So, therefore, what you can do is, you hanya focus for x sajalah, which you bring up the dx, just put beside the x over here, become like this. Right? After that, you just integrate as usual. Integrate macam biasa. But now, walaupun dia tak ada any parameter ke, any variable, any constant in front of dy, actually dah ada 1. Okay, so therefore integrate 1, you can dapat y, and just put this the first constant, and integrate of x is x squared over 2, is it? So sebab tu dapat ini. Right, so therefore move the c1 to the right hand side. So therefore you dapat y 1/2 x squared plus c, where c equal to c2 minus c1. And usually kita keep as a positive c lah. Jarang kita letak as a negative c. Okay, so again you can put this y as a subject over here. Okay, this one is also one example. Okay, but a bit different over here. You can see from here, if you have x dy over dx equal to y, definitely you akan pecahkan jadi macam ni lah. Okay, again put y at one side, x at one side, and if you notice, you akan dapat 1/y dy equal to 1/x dx. Okay, I nak highlight over here. If you open the page number 402, that explain a bit when we integrate logarithm. Okay, you akan dapat only at the right hand side dia akan produce 1/x dx, they will produce ln kx. Okay, kenapa? Because in the page number 402 they explain. Okay, for example, if you differentiate, for example, ln 3x, okay, you akan produce 1/3x, and then you differentiate dengan multiply with, you differentiate the function inside the bracket, become 3, is it? So kalau kita solve, you can dapat 3/3x, later you dapat 1/x. So actually sama lah macam ni. So therefore, in the page number 402, you open page number 402, they explain. Suddenly, when you integrate at the right hand side sahaja, right hand side, left hand side ni tak ada apa. Actually, no need to put the plus c. Explain in 402. Okay. You boleh gunakan this method also, or you may use my method over here. Actually, dia akan produce the same answer. Okay, so back to this 402. Okay, now on the right hand side, they will produce yang ini, rather than you put plus c2. Tadi kan kita buat any integration, dia akan produce c1 and c2, right? But this is special case for integrate of reciprocal function. Dia akan produce ln modulus kx. Dia tak perlu letak plus c2. No need to put plus c2. Okay, they put as a kx. Okay, kenapa tadi I explain dah. Okay, refer to page number 402. Okay, or I lagi prefer this method 402, or you may follow my method over here. Okay, which is you just simply put C1 and C2 at both sides. And after that, again, you do the same thing, which is you put the constant at one side, which is letak dekat right hand side as C. But then you will have Y, because ni ln, right? So therefore, ln ni actually log both base exponent Y, right? So refer to the notes of solving the logarithm, which is in order to put Y as a subject, you have to put this Y, put the exponent to the other side. Sebab tu dia jadi macam ni, right? Therefore, you separate. Okay, macam mana boleh separate jadi multiplication pula suddenly? Okay, because when you have a same base and you multiply, therefore dia akan tambah. Contoh, exponent x plus multiply exponent 4 actually sama dengan exponent 4 plus x of x plus 4. Okay, so sebab tu kita dapat produk macam ni. Ini unit backward from here to there, right? So therefore kita separate exponent ln, exponent power exponent, exponent log exponent of x, tinggal x sahaja because you boleh cancel out di sini. So therefore dapat x. But for exponent power of c is a constant where c equal to exponent of c. Constant ni very subjective. You multiply constant to constant, still a constant. Even though kalau you are the index with power constant, it's still a constant. So sebab tu kita let us see. Alright. This one another example. Okay. So let's apply using the explanation in page number 402 in order to solve this question rather than use the C1 and C2. Okay. So after you separate according to the variables, y with y, x with x. Okay. Kat sini is very subjective. Okay, first thing first, let's take a look this negative. Okay, usually any constant yang multiply to the variable, you should bring everything. Ataupun kalau you tak nak bring everything, you boleh let you just bring only the variable. Okay, kalau delta ni dia suggest untuk bring saja constant, bring saja dia punya variable. So therefore dia dapat 1 over y. Okay, so they keep the negative at the right hand side. Okay, actually kalau you bring sama jugalah, nanti later you akan dapat negative lah di sini. Tapi usually kita hanya bawa variable sahaja. Okay, so let's take a look. Right now, you ada integration of 1 over y. Tadi kita dah kata kalau untuk right hand side, you kena multiply with k, is it? Alright, so actually kalau dia last dekat left hand side, okay, you boleh apply juga benda yang sama. Tapi I not really encourage you, okay, sebab takut you confuse pula. So boleh gunakan juga untuk ini. So therefore you akan dapat ln ky, ln ky. You boleh tengok from delta dia ada gunakan ln ky, tapi I not really encourage you sebab takut confuse. Sebab the y and x is two different variables, independent and dependent variables. Okay, actually boleh gunakan juga yang sama ln ky, tapi I really encourage you untuk gunakan C1 dan C2. Okay, actually dia produce jawapan yang sama juga, even though a bit different lah. Maybe you tak akan ada k in your final answer, tapi ada method untuk check tapi tak masuk dalam syllabus. So therefore I don't want to discuss anything yang tak masuk dalam syllabus lah, takut you jadi haywire nanti. Okay, so focus on put the constant at both sides, and therefore you just put as usual, C equal to C2 minus C1, and after that, in order to put Y as a subject, you have to move this ln. So therefore you akan dapat yang this one lah. Okay, which is you put the base the base of the ln over here as as the base, and then the number over here become the power, right? And then separate like usual. Okay. All right. So therefore, let's try this exercise 23.05 in the next video.